Now we go to fundamental problem 10.1. In this question, basically you have this xy axis, okay, and then you are given this curve with function of y cube equals to x squared, alright, and then you know that this point is 1 1, this is 0 0, okay, this is 1 1 meter in the equation, which means that this point is 1 and then this point is 1 as well, alright. So the question asks you to find what is the moment of inertia of the shaded area about the x-axis. So moment of inertia will always about that, about an axis, whether it's x or y or any particular axis. Okay. So in this question, the question asks to find what is the moment of inertia I, right, about x-axis. So ix, right. So the thing is, as explained in the lecture, you can choose even for like chapter 9, the centroid, you can choose a differential element. You remember the strip, either is horizontal or vertical or horizontal, right? You can choose this differential element dA either way. I mean, you can choose horizontal or vertical, no problem. But actually, in this problem, when you are asked to find the moment of inertia I about x-axis, actually the best way is to choose differential element which is parallel to x-axis itself. Okay, but nonetheless, actually now here for this 10.1, I want to choose the differential element which is perpendicular, right, to this axis, and we will look at another example for that one. Okay, so if you choose this differential element, so this point is xy, right? Because it's xy based on this curve. And then when you have the centroid here, this is the centroid which is x tilde and y tilde, right? And then for this differential element, this is your neutral axis, which is the x bar. Okay, so the x prime. X prime is the axis through the centroid, which is parallel with the x, the general x that you want to find about, right? So to find this, actually for this kind of, if you choose the differential element strip which is perpendicular to the axis that you want to find moment of inertia about, so the equation is given as dix, okay, differential ix equals to dix prime, alright, plus dA y bar squared, alright. So actually everything here is given. What is the ix? For this shape, which is what? Let me explain this first. Okay, this is x. The x, right? This is x. How about this? This is y, isn't it? Y, right? And what is this? This is y tilde, which is y over 2 in this case, y over 2 half of that, right? So your dix is, for this differential element, the moment of inertia about this x prime axis, right, its own centroidal axis, it is 1 over 12 bh cubic, isn't it? You're given this in the lecture, right? So your b, okay, b h cubic. So what is your b? Your b is dx, right? And your h is y, right? So y cubic. It's okay. And then plus dA is differential area, which is dx times y, isn't it? Dx times y, but dy is your y itself, so dx times y, right? And your y tilde is y over 2, okay, y over 2 square. Okay, so this is your dix. Alright, so if once you can you see that this is actually dx, right? You can take this out. In fact, this one is y cube, and this one will be y cube, right? So you have both terms, dxy cube, both of them. So 1 over 12 plus 1 over 2 will be 1 over 3. So your dix, if you simplify, you will get 1 over 3 dxy cubic. Okay, or actually the more correct way is y cubic dx, right? Because later on we want to integrate, right? So your ix, it is integration of this. You do integration, right? This is the ix. You do integration, and then it will become ix equals to integration of this. So you have 1 over 3 y cubic. What happened to y cubic? Y power of 4, isn't it? Plus 1. And then 1 over 4 you take. Okay, if you do integration, right? So you need to choose from where to where. So here you do the integration with respect to x axis. So this area is between x equal to 0 to x equals to 1. So this one actually you do the integration, right? This one you do integration from 0 to 1, x equals 0 to x equals to 1, 1 over 3 y cubic dx, right? So from 0 to 1, substitute the value of that. Of course, will be 0, 1 plus 0, 1 minus 0, right? So it will be 1 over 1 over 3y power of... Oh yeah, sorry, mistake. Sorry about this. This is y cubic, okay? You do integration with respect to x, right? So you have to change this y. So what happened is, this y cubic, you have to substitute with the x term, right? So in this case, y cubic is x squared. So you have 1 over 3 integration from 0 to 1 x squared dx. Okay, this y cubic is x squared. Alright, so because you integrate here with respect to x. So you have ix equals to 1 over 3, okay, x cubic over 3, right, from 0 to 1. Of course, 1, if you put 1 power of 3 minus 0 power of 3, it will be 1, so it will be 1 over 9 meter power of 4. Okay. Why 1 over 9 meter power 4? 1 over 9 is fine. This is the numerical value here. But why meter power 4? Because this is 1 meter. This is 1 meter, right? So the unit here is meter. And for your moment of inertia, the unit of length is raised to the power of 4, right?